Okay, this video is for 11.5a, significant features of absolute value functions. So today we're going to talk a lot more about the actual equation for an absolute value function and what the information within the equation tells us and how we can identify the equation from a graph and how can we identify things like vertex, if the graph opens up or down, how it shifts, that kind of thing. So let's start by talking about 1, 2, and 3, and then we will go to the back page. So the value of h, which you can see right here, accounts for movement of the graph left and right. Just like we've seen in square root graphs, cubic graphs, and square graphs, all those types of things, that x minus h piece, the h shifts the graph left and right. And just like we've seen in those graphs as well, and this moves on to number 2, the value of k accounts for movement of the graph up and down. So h is a shift left and right, k is a shift up and down, and the two of them written together as h comma k as a point is called the vertex, which is very similar to what we've seen in the past as well. Now, actually, let's do number 4 as well. So what does the value of a tell us? A right here. Well, it's just like we've seen in those other graphs as well. If a is positive, the graph's going to open up. If it's negative, it opens down. So a tells us whether it opens, and open is the key word, opens up or down. Alright, now let's apply this to a couple challenging problems, or one challenging problem on the back. So let's do number 15. They've given us a graph and they want us to identify a couple things: how it opens, its axis of symmetry, its vertex, and then the equation. So zoom in closer here. From this graph you can clearly tell that this opens up. So when we write our equation, we're going to have an a value that is positive. And the axis of symmetry is a line, a vertical line that goes straight through the vertex of our graph. So the axis of symmetry, since it's a straight line, it has an equation, and a line that goes through a vertical line is an x equals equation, and it goes through x equals 6. So our axis of symmetry has the equation x equals 6. Now the last thing they want us to do is figure out the point where our vertex is at, and as you can see, that is at point 6 comma negative 6. So if we want to make our graph, or our equation for the graph, the easiest thing to start with is the vertex, because those are our h and our k values within our equation. So h is in between the absolute value symbols, and since we have a positive x value, positive 6, remember our h has to be the opposite, so it's going to be x minus 6. And then on the outside, our k value, which will go here, which corresponds to our vertex's y value, is exactly the same, so we don't change the sign. So that one is also minus 6. That's terrible. Now, the toughest part of this equation is determining what our a value should be. We definitely know it has to be positive, but we need to figure out what number it is. Now, on a typical, or on your general absolute value function graph, if you look at the vertex, every unit to the right you go, typically you'll go up 1 unit. And then you go to the right one, up 1, right one, up 1. As you can see in this graph, that's not happening. What's happening here is we're going right 1, but then we're going up 2. And then right 1 and up 2. and then right 1 and up 2. So this graph is being stretched 2 times bigger than it usually is, which means the a value needs to be positive 2. And now we have finally created an equation for this graph.